All right. Oh, but you know what? I forgot to start up my HoverCam. No telling what they've been looking at right now on that first couple minutes of that video. All right, piecewise functions. This is good. We just had a test on this. We just had a test on all these functions. And so what you're doing is you're literally piecing together several functions at the same time. So we're going to use everything we just turned in on that test, and we're going to piece together multiple functions. Now, you also have a specific domain in, oh, we forgot to talk about our question. Oh, okay. You have a specific domain for where that function occurs. So what this is matching, and I just wanted to start out with something easy, but it's a good example. So let's look at let's start with the easy one. Let's start with 26. This one's really easy right here. Okay, so what you do, this is how I would do this, is I would look at the first one, and it says, all right, if the function is negative x squared. Now, what does negative x squared look like? We just had a test on this today. What's the shape of negative in front of x squared? Correct. This is going to be a downward U, so you got to keep that in your pocket. What is the shape of positive x squared? Upward, okay? So those are the two pieces, and then it tells you to do this piece if x is less than 1. And then you're going to do this piece if x is greater than 1. Okay, so if x is less than or equal to, excuse me, I should have said that. If x is less than or equal to 1, it's going to take the downward U-turn. But if x is greater than 1, it's going to take this one. So you're putting the yellow graph and the green graph together. Now, let's look at our options. So let's see if I can slide this up so we can see the options. All right, let's start with the green. So if your x's are greater than 1, let me get a piece of paper. All right, so greater than 1 would be there. Okay, that looks like a straight line to me. That does not look like a parabola. We know we want a parabola from 1 and to the right, so I'm thinking that's not it. Let's look at B. All right. I'm definitely not thinking it's B because of that closed-in circle, and then there's something going on over here. That looks really complicated. All right, let's keep going. He said C. I'm not feeling good about C because it should be going up where it's greater than 1. Keep going. Go over to 1. Nope, not D. All right, let's look at E. All right. Well, is it going up past 1? My blue paper is representing where 1 is. Is it going up past 1? Yes, so far that's the only option. Let's look at F. All right, F, kind of, sort of, maybe could be F, but I'm thinking not because I noticed that F has a weird thing. Let's look at E and talk about why it is E. It is E, and it's hard for me to put these on the paper at the same time. But this says it's going to do an upward U if X is greater than 1. Well, what kind of circle did we have at 1? It's hard to see. Let me pull this up. Open circle and pointing to the right. Now, personally, this looks like a perfectly straight line to me, and we know that quadratic equations do not follow a perfectly linear curve, but we'll have to work with what we got. And then it says, let me write down what it said up here. I'm just going to write it beside here. All right, g of x equals, you've got negative x squared if x is less than or equal to 1. Positive x squared if x is greater than 1. So I'm liking that open circle goes with the positive side, and then it's going to look like a down U. We had already decided the top one is a down U. We had already decided the bottom one is an up U. So to the left of 1, to the left of 1, this is 1, I'm putting the blue paper where 1 is it making a downward shape? Yes, it is. Now, the open and the closed circles are important. Why does it have an open circle with this piece? These are called piecewise functions. This piece has an open circle, but this piece has a closed circle. Right, because it's included. This has an equal to. Did I copy that correctly? Yeah. This has an equal to, and this one does not. So it would be an open circle for everything greater than 1. It would be a closed circle for everything less than 1. So the answer to 26 goes with graph E. Let's look at 31. Let's do 31. I love this stuff because it's kind of like a puzzle. All right, let's look at 31. So we have two situations. We have this yellow situation, and then we have this green situation. Now, before I get crazy, I just want to review my stuff that I just turned my test in 30 minutes ago and get an idea for what the basic graph is going to look like. So x squared is going to be a quadratic, so it's going to look something like that. And an absolute value graph should be a perfect V. So those are the functions. I'm sorry, you can't see that. Those are the functions that we just had on our test, okay? If you got that. And then we have to look at each piece. So it's going to do an up U between -1 and +1. Well, let's check it. What does this look like it's doing between -1 and +1? An up U. Looks pretty good to me, but let's just analyze the other ones. All right, is this one doing an up U, a quadratic, between -1 and +1? No, it's not. It's some kind of cube. Same thing here. This is some kind of cube in between -1 and +1, so that's not it. This is just looking wacko, plus this has 3 parts, and 3-part functions go with 3 equations. See what I'm saying? So it's got to be A. Now let's confirm the other part. It says if x is less than 1, it's going to do the absolute value thing, or if x is greater than 1. Well, less than 1. Does this look like what an absolute value graph would do? Yes, it does, because remember, it goes out straight. And then to the right of 1, this also looks like what an absolute value graph would do. So the answer to, which one is that? 30, 31? 31 is A. All right, is there only one that has a 3-part graph? I thought there was. How many graphs are there? 2, 3, 4, 5, 6. 1, 2. All right, let's do one more. Let's do 28. Let's do 28. All right, so let's go to 28. It has 3 pieces. It has 3 pieces. So this is piece number 1. That's going to be a linear equation. This is piece number 2. That's going to be a cubic. And then piece number 3 is also a linear equation. It doesn't really look like y equals mx plus b, but it is. Now, just today, I passed back, Ethan loves all of the paper that we use in here. But today, I passed back a pink packet. And the pink packet was linear equations in standard form and slope-intercept form. That is another topic. We spent some class time on it, but it was not on the it's not on the final exam. So this is the same way. But that is going to tie into today's lesson, because if you can't graph a line, you're not going to be able to figure out which piece it is. Let's start with the easiest one. We just turned our test in for x cubed. We know that x cubed is going to look something like this. It's going to be like a vertical snake going through the origin, and it's going to do this if it's between -2 and 3. So let's kind of, it definitely can't be A. We've already used A. It can't be E. So it's either B, C, D, or F. Let's see. Okay. So in other words, between -2 and 3, it's going to look like a vertical snake. So -2 and 3. Is that looking good? Colin, what kind of circle should we have at -2, since this says less than or equal to? What kind of circle would be at -2? Solid. Now notice this has a solid circle at -2. And then, Colin, what kind of hole would you have at 3? An open. Notice this is an open circle at 3, and this is a closed circle at -2. I'm already feeling like the answer is B. I mean, I probably should keep checking, but we'll go. All right, let's look at this. This is very, very important. I just passed the linear and exponential packet back to you. But let's go to Kayla. Kayla, what is the slope in front of this x, even if you can't see it? 1. So our slope is 1/1. There's your slope. And this is your y-intercept. So this says if x is less than 2, okay, that would be over here. Less than 2's are over here to the left. It should go up 1/1, up 1/1, up 1/1. And it should hit the y-axis at 1. Now let's see if this looks like it's doing that. Does it look like it's going up 1/1, up 1/1, up 1/1? Does it look like it's doing that? Okay, let's keep going and just see if it would hit at 1. So if we go up 1/1, up 1/1, up 1/1, would it hit at 1? Yes, so that's the second piece. And then the last one is -1x minus 1. If you don't like the way that's written, you can rewrite it in slope-intercept form, -1x minus 1. Your slope would be -1. Your y-intercept would be -1. And so you're going down 1, right 1, down 1, right 1. Now, one thing that's important to note is what kind of circle should have been at -2 for this particular part of the graph? Open. See how this has an open circle right here? What do you think you're going to do after we do this matching activity? No, not yet. Do our question. But you're going to have to graph them yourself. So this is just a warm-up, right? All right, and then if you look at 3, it should have been a closed circle. So 30, no, what number am I on? 28. 28 goes with B. 28 goes with B. 28 goes with B. All right, you only have a couple more, excuse me, that was grammatically incorrect. So I want you to work on that just for a minute or two. Let's figure out there's only 3 remaining, 25, 27, and 30. We've already used E, B, and A. So just work on that for a minute or so. So this needs to be just as packet when these first go.
Have you turned these yellow papers in?